equation, our revenue equation, we got it up there as 80x. How about the cost equation? The cost equation, ladies and gentlemen, we got 0.5x squared, right? Please remind me, minus, is it minus 100x plus the fixed cost, which was what here? 250. The fixed cost, which was 250. But remember what the question wants us to do. The question wants us to ascertain. The question wants us to ascertain, right? Yes. The question wants us to ascertain profit equation. And you and I know the fact that our profit is revenue minus cost. So our profit will be revenue, which is 80x minus the cost. I've got to put this cost in brackets. I must put the cost in brackets because the cost has got 3 terms. And I would want to subtract all the terms from my revenue. So the cost here is 0.5x squared minus 100x plus 250, like that. So my profit here will be 80x minus 0.5x squared. This, of course, changes. And it becomes plus 100x minus 250. Minus 250. When I'm subtracting my terms, ladies and gentlemen, remember when I'm subtracting my terms, what I need to do is to come and ensure that I change the signs of the terms, all of them. I change them like that. So after this, what do? I'll come and put like terms together. So putting like terms together, what do we have? This and this are like terms. So then that will give us 180x. Minus 0.5x squared, because this does not have a partner. So I simply bring it with a sign. And then now we have minus what here, somebody? 250. That is what we were required to do in that question. Ladies and gentlemen, if this examiner was to give us this kind of a question this time around, quadratic function, and then he expects us to go through the processes that we have gone through today, is there a student here who can promise me, Mwalimu, up to here, I'll be able to get all the marks from what you've done today? If the examiner was to bring this kind of a question, is there a student who is saying, Mwalimu, I've been able to follow up to there? If that is you, you simply say Y for yes. Y for yes. Y for yes. So when he says up to there, even Grace, up to there, I'll be able to get all the marks. What about the other students? Of course, it means that you may need to watch the video or you practice more. Thanks, Langat. Great. Now look at number 2. Actually, number 2, I don't even have to do it because number 2, you guys are so good at number 2. Number 2, they want us to talk of maximization, the maximum. Maximum. What do we know about this maximization? Very easy. To maximize, ladies and gentlemen, we use differentiation. To maximize, in this case here, use differentiation. Specifically, what we call the first order. The first order condition. The first order what here? First order condition, FOC. FOC. So remember that first order condition states that first order condition states that the gradient of a curve, the gradient of a curve at a turning point, turning point could be either maximum turning point, or minimum turning point. Maximum turning point or minimum turning point. So FOC states that the gradient of a curve at a turning point, whichever turning point, is always 0. Is 0. The gradient of a curve The gradient of a curve. When you have a curve like this, ladies and gentlemen, this curve, the gradient up here, if I was to introduce a tangent, the gradient up there will be giving me a flat tangent. The tangent there will be flat. And if the tangent is flat, then automatically that tells me that the first order condition is 0. So if that is the case, then we should always differentiate the function you want to maximize. Like now here, they want us to maximize profit. Then the thing we have to do is to come and maximize the profit by differentiating the profit function. So in this case here, differentiate the profit function. Unaweza ama huwezi? So this is the profit function. Can somebody help me differentiate? It is d profit over dx. Let me remain silent a little bit. You guys, I would want you guys to give me the d profit over dx. Tell me, what do we have there? D profit over dx, what do we have? D profit over dx, what do we have? The function, ladies and gentlemen, will be, if I differentiate, this becomes 180. I think, to be fair, allow mwalimu here, allow mwalimu to remind you of the basics of what here? Differentiation. Allow mwalimu here to remind you the basics of differentiation. So if you're given like y equals ax raised to power n, how do we differentiate dy over dx? So dy over dx, ladies and gentlemen, to differentiate here, you take n down. So then this will be an x raised to a reduced power. So we take the old power minus who? 1. We take the old power minus who? 1. So if, for example, you are given like y equals 10x raised to power 5, to get dy over dx, the 5 has to fall down. So it will be 10 times 5. That gives me 50. X raised to a new power. And the new power will be the old power minus who? 1. The old power minus 1, which will give me 4. Ladies and gentlemen, as a quick reminder of what we've been doing in differentiation, if you're given here y equals 10x plus 50, 10x plus 50, then dy over dx will be equal to what? Dy over dx will be equal to what? Dy over dx will be equal to what? Ladies and gentlemen, remember that there is an implied 1, power 1 there. And when this power comes down, then automatically this will be 10x raised to 0. And for us, any letter or number which is raised to 0, that is as good as 1. This will be the same as saying 10 times 1. And of course, this is a constant because it doesn't have x. If it's a constant, when you differentiate constants, ladies and gentlemen, they do what? They always disappear. When you differentiate constants, ladies and gentlemen, they always do what here? Disappear. So if that is the case, ladies and gentlemen, then look at this. This will remain as 180 minus, please bring this down. This will be 0.5 times 2, which gives me 1. So 1 what here? X. So then this becomes minus who? X. And of course, this is a constant which disappears on differentiation. And remember, the rule of first order condition is that this should be equal to what here? The first order condition tells us, ladies and gentlemen, that this differentiated should be equal to 0. So then if that is the case, ladies and gentlemen, our x at the end of the day will be equal to 100 who? X will be equal to 180. And if x equals 180, please go back to the question. Go back to the question. Remember what they wanted us to do. They never wanted us just to give them the quantity which maximizes profit. They wanted us, ladies and gentlemen, to ascertain the maximum profit. So how do we get the maximum profit? We substitute for this in the profit equation. We know that profit equals 180x minus 0.5x squared minus 250. And then when x equals 180, then profit here will be equal to what? Then profit here will be equal to what? Profit here will be equal to what? Profit here will be equal to what? So please try to plug in there. Try to plug in there, and then you advise us. So this will be 180 times 180 minus 0.5 times 180 squared minus 250. Please give me an answer. 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 So what answer are we getting? What answer are we getting? Somebody talk to me, talk to me, talk to me. Use your calculator. Use your calculator, use your calculator. So according to Grace, we are getting 15,950. 15,950. 15,950. 15,950. 15,950. So thank you very much, ladies and gentlemen. Unfortunately, I'm supposed to be picking up